All right. Now let's look at dimensions of units or dimensional analysis of units. So when we talk about dimension of units, unit dimension, okay, there. When we talk about unit dimensions, what we are saying is we are trying to see how the following fundamental quantities, length, mass, time, and what? Current. Talk about dimensions of unit. We want to see how these fundamental quantities, length, mass, time, and current is used to show how the relationship that is used to show the relationship of fundamental units of a physical quantity. To show the relationship of fundamental units in a physical quantity. So when you talk about unit dimensions, you are simply looking at how you use these four fundamental quantities. Understand? How you use them to represent the relationship, how you use them to show the way they relate in other quantities or derived quantities. Okay, take for instance, if you talk about area, what is the dimensional unit for area? We know that the formula for area is what? Length times what? Breadth. And you know that this breadth is also a length on its own. So if you represent them in their fundamental quantity, this is length times length, which equals to what? Length squared. Understand? So the dimensional unit for area is what? L, capital letter L raised to power of 2. Capital letter L raised to power of 2. If you look at the unit volume, volume is length times breadth times height, in which in the fundamental unit way, this is length times another length times another length. So the dimensional unit for volume is what? Length L raised to power of 3. Are you following? So we're going to take examples and find out some dimensional unit for some for a more derived quantities. Okay. Okay, let's try let's try another unit. Let's say speed. What's the dimensional unit for speed? We know that speed is what? Distance over what? Time. And distance in this fundamental form is a length. Time itself is a fundamental unit. So the dimensional unit for speed is what? Capital L over capital T, or you write it this way, LT raised to power minus 1. Because of indices. You know, indices says that if you have x raised to power of minus n is the same thing as 1 over x raised to power of n. So since t is below, if you take it up, it becomes minus. So that is for speed. Let's look at the dimensional unit for acceleration. Or the dimensional unit for acceleration. We know that acceleration is velocity over time. And we know that velocity on its own is what? Displacement over time. Then over another time. And then we know that displacement of its own in its fundamental form is a length, and time is also a fundamental unit over another time. So the dimensional unit for acceleration, if you do the mathematics here, will be length over time squared, which is the same thing as length times time raised by minus 2. So this is the dimensional unit for acceleration. We will proceed and look at the dimensional unit for other derived quantities, because this dimensional unit of a thing usually come in exam, only come in a very tricky manner. So it's not something to overlook. So let's look at another unit like work, or okay, force. We know that force is what? Mass times acceleration. In the fundamental form, mass is written as m, which is still it. And then we know the one we just finished calculating, the fundamental unit of acceleration is what? Length times time raised by minus 2. So when you combine, the dimensional unit for force is what? mlt raised by minus 2. So the secrets to knowing the fundamental units of any derived quantity is to know the formula, or you say the definition of that quantity. So what's the fundamental unit for density? For mass density. Density is defined as the ratio of what? Ratio of mass to volume. Density is defined as the ratio of mass to volume. So, and mass itself in fundamental form is m, is a fundamental unit. Volume on its own in a fundamental form is 3 length. That's length times length times length. That's L raised power of 3. So this would be mass times L raised power minus 3. So this is the dimensional unit for density. How about dimensional unit for work done? The formula for work done, or we say the definition for work done, is force times what? Distance. Force times distance. So, and already we know the dimensional unit for force. We already wrote that. That's mlt raised to power minus 2. mlt raised to power minus 2, then times d. D fundamental form is L. So work done will be m L raised to power of 2 t raised to power of minus 2. So if we are to take one more before we end things there, the dimensional unit for pressure. So, unit for pressure. Pressure, okay, what's the formula for pressure? Pressure is defined as what? Force over area. Force over area. And the dimensional unit for force is mlt raised to power minus 2. And area is what? L raised to power of 2. So one of these L will cancel one of the L in the denominator. So you'll be left with ml raised to power minus 1, t raised to power minus 2. So this is the dimensional unit for what? Pressure. So that is it about dimensional unit. So the way the questions usually come, they might ask for the dimensional unit for any quantity. All you have to do is just know the definition of that quantity or the formula. From there, you'll be able to extract the fundamental quantities there. Before we conclude, one more. We have not done the one that includes current. Okay, so what's the dimensional unit for charge? What's the dimensional unit for charge? charge, Q. And we know the definition of charge is what? Definition of charge is current times what? Time. And current is a fundamental unit of its own, which is represented by capital letter I, times T is a fundamental unit, which is represented by T. So the dimensional unit for charge equals to what? IT. As simple as that.